Friends, welcome to the class. Today we'll discuss about application of trigonometry. That means, in this chapter we'll discuss how in day-to-day height and distance can be calculated with the help of trigonometric formulae. Measuring height and distance is an important aspect of trigonometry. In this chapter we'll learn the use of trigonometry in measuring height and distance of towers, buildings and other objects. So before we go further, let us be familiar with some particular definitions like line of sight. The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. Angle of elevation. The angle of elevation is an object viewed is the angle formed by the line of sight with horizontal when it is above horizontal level. That means it is the case when we raise our head to look at the object. Angle of depression. The angle of depression is an object viewed is the angle formed by the line of sight with the horizontal when it is below the horizontal level. That means it is the case when we lower our head to look at the object. We'll see with the help of a picture. Let's consider this picture. In the given picture, angle ADC is the angle of elevation when the line of sight is CD viewed from the point D. That means if a person or an observer is watching from the angle D and he is standing somewhere on the surface of CD, then this angle ADC, that means this particular angle, or suppose he is looking at an object lies at the point A, then this angle ADC is called the angle of elevation because he is raising his head to see this particular object. Likewise, angle BAD is the angle of depression when the line of sight is AB and viewed from the angle A. Suppose the observer is standing here and he is looking from this particular angle and he is looking at the point D. That means he is lowering his head. The person is lowering his or her head. So this angle BAD, is called the angle of depression. We need to keep in mind some important notes. Let's see them. A plane or line parallel to the surface of the earth is called horizontal plane or horizontal line. That is, when we come across this kind of problem, any surface which is perpendicular to the surface of the earth, let's say CD or AB, they will be called as a horizontal plane or horizontal line. If the observer moves towards the perpendicular line may be a tower or a pole or a building or a pillar or a wall, the angle of elevation increases and vice versa. So if in this picture, let's say D is an observer, or the observer is standing near D. The moment he comes close to AC, what is AC? AC is a perpendicular line. The moment he comes close to AC, the angle of elevation keeps on increasing, and vice versa. That means the moment he moves away from AC, the angle of elevation, it keeps on decreasing. If the height of the perpendicular line is doubled and the distance between the observer and foot of the perpendicular line is doubled, then the angle of elevation will remain same. Let's say we are doubling the length of AC and that of CD. That means in this case the angle of elevation will remain as it is. If both horizontal as well as the perpendicular line, the length of both horizontal and perpendicular line are increased in the same rate, then the angle of elevation or angle of depression will remain same. If the angle of elevation of sun above a tower decreases, then the length of the shadow of the tower increases and vice versa. Let's say AC is a tower and the sun is just near AC, the point A. So that means if AC is the tower, CD will represent its shadow. If the angle of elevation of sun above the tower decreases, here Let's say sun is making the angle of elevation is D. The observer is looking sun at through the point D. So angle D is representing the angle of elevation of the sun. If the angle of elevation decreases, that means if D decreases, means if sun comes to this side, then obviously the angle of elevation will decrease. That means the length of CD will increase. But what is CD? CD is nothing but the shadow. Shadow will increase, and this is what they are saying. The angle of elevation of sun above a tower decreases, then the length of shadow of the tower increases, and vice versa. Means if the angle of elevation of the sun decreases, that means the value of D decreases, the shadow will increase. And at the same time, if the sun comes to this side of the A, that means the length of shadow will decrease, means the angle of elevation will increase. The angle of elevation and depression are always in acute angles. That means both the angle of elevation and angle of depression will not be more than 90 degree. It will be less than 90 degree. It is the acute angle. The angle of elevation at a point A as seen from point D is always equal to the angle of depression of D as seen from the point A. Means the angle of elevation of the point A as seen from the D. Suppose the observer is looking from the point D to A. This angle of elevation, it will be same if the observer sees from A to the point D. It will remain the angle A will remain equals to angle D, that is angle of depression. The angle of elevation of the point A as seen from D is always equal to the angle of depression of D as seen from A. If the observer sees at angle A from the point D, the angle made at the angle D will remain as the observers look at D from the point A. These two angles will remain as it is. Let's see some examples. If 300 root 3 meter high tower makes an angle of elevation at a point on the ground which is 300 meter away from its foot, then find the angle of elevation. Let's first draw the picture. So let AB is the tower whose height is 300 root 3 meter and C be the point for the angle of elevation. Now AB is 300 root 3 and AC equals to 300 meter. Let the angle of elevation be theta. Now in right angle triangle, triangle BAC equals to tan theta is tan theta equals to AB by AC because tan theta is perpendicular by base. So this implies tan theta equal to 300 root 3 by 300. That means tan theta is equals to root 3. But what is root 3? It is nothing but tan 60 degree. That means theta equals to 60 degree. Hence, the angle of elevation is 60 degree. A bridge on a river makes an angle 45 degree with its edge. If the length along the bridge from one edge to the other is 150 meter, then find the width of the river. Let's draw the picture first. Let BC be the width of the river and A, B are the ends of the river such that AB equals to 150 meter, which is nothing but the length of the bridge. Here angle BAC equals to 45 degree because here already it is given the bridge on the river makes an angle 45 degree with the edge. This is the bridge and it makes an angle 45 degree with the river, and here is the river. So in right angle triangle ACB, sine of 45 degree equals to BC by AC because sine is theta equals to P by H, or the value of sine 45 degree is 1 by root 2, 1 by root 2 equal to BC by AB, or we can write 1 by root 2 equal to BC by 150 because AB is 150 meter, or BC equals to 150 into 1 by root 2, which is nothing but 75 root 2. It is 75 into 1.414, which gives to 106.05 meter approximately. Thus, the width of the river is 106.05 meter. A man in a boat rowing away from the lighthouse, 100-meter high, takes 2 minutes to change the angle of elevation of the top of the lighthouse from 60 degree to 30 degree. Find the speed of the boat. So if we consider the picture here, let AB be the lighthouse, C, D are the position of the man when the angle of elevation changes from 60 degree to 30 degree. The man covered the distance CD in 2 minutes. That means AB is the lighthouse. Earlier the man was at the point C when the angle of elevation was 60 degree with the top with the point A. The moment the man reaches the point D, the angle of elevation reduced to 30 degree. And this distance from C to D the man covered in 2 minutes. We need to find the speed of the boat. We know speed equal to distance by time, or we can write speed equal to CD by 2 because here distance covered by the man is CD. He came from C to D in 2 minutes, so CD by 2. The right angle triangle ABC tan 60 degree equal to AB by BC, or you can write root 3 equals to 100 by 100 by BC, or equals to BC equals to 100 by 3 root 3 which is nothing 100 root 3 by 3 meter. Again, in triangle ABD, tan of 30 degree equals to AB by BC, or we can write 1 by root 3 equal to 100 by BD, or BD equals to 100 root 3 meter. Now CD equals to BD minus BC, so we can write it is 100 root 3 minus 100 root 3 by 3, or taking 100 root 3 common, it is 100 root 3 into 1 minus 1 by root 3, which is another 100 root 3 into 2 by 3. Now what is speed? Speed equals to CD by 2. Already the value of CD is obtained, so we can find speed equals to 1 by 2 into 100 root 3 into 2 by 3, which is nothing but 100 by root 3 meter per minute. Hence, the speed of the boat is 100 by root 3 meter per minute. Is the answer. The angle of elevation of the top of the building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, then find the height of the building. Let's draw the picture first. Let BC be the tower and AD be the building. That means here BC is 50 meter, and we need to find out the height of the building. So BC equals to 50. Now angle of elevation of the top of the building from the foot of the tower, that means angle DBA equals to 30 degree, and the angle of elevation of the top of the tower from the foot of the building, that means angle CAB, this is equals to 60 degree. AB is the distance between the building and the tower. Now in right angle triangle, angle BAD, tan of 30 degrees equals to AD by AB, or we can write 1 by root 3 equals to AD by AB. This implies AD equals to AB by root 3. Let this is first equation. Again in right angle triangle CBA, tan of 60 degree equal to BC by AB, or it is root 3 equals to BC by AB, 50 by AB, or we can write AB equals to 50 by root 3. Let this is second equation. Now putting the value of equation 2 in equation 1, we get AD equals to 50 by root 3 into 1 by root 3, which is nothing but 50 by 3, or AD equals to 50 by 3, which is nothing but 16 root 3, 16 and 2 by 3. Thus, the height of the building is 16 and 2 by 3 meter. Is the answer. Two poles are of equal height are standing opposite to each other on the either side of the road. The road is 80 meter wide. From an arbitrary point on the road, the angle of elevation of two poles are 60 degree and 30 degree respectively. Find the height of the poles and the distance of the point from the poles. Let's draw the picture. So we can say here BD and AE are the two poles and AB is the road, and C is any arbitrary point which makes the angular elevation 30 degree and 60 degree with two poles. With poles AC it is making 30 degree and with pole BD it is making 60 degree respectively. That AB is the width of the road, so AB equals to 80 meter. AE and BD are the two poles standing on both sides of the road, that means AE equals to BD. The arbitrary point BC such that the angle of elevation, that means angle BCD equals to 60 degree and angle ACE equals to 30 degree. Let BC equals to x meter, because we have to find out the individual distance of the point from the individual poles. Let BC equals to x meter, so AC is nothing but AB minus BC, which is 80 minus x meter. In right angle triangle CAE, tan of 30 degree equals to AE by AC, or it is 1 by root 3 equal to AE by 80 minus x, or you can write AE into root 3 equal to 80 minus x. Let this is first equation. In right angle triangle CBD, tan of 60 degree equal to BD by BC, or we can write root 3 equals to BD by x, because BC we have taken to be x, or it is x equals to AE by x. Why AE by x? Because BD and AE are the two equal poles. So in the place of BD we can write AE, given that two poles are equal in height. Or you can write AE equals to x root 3. Let this is second equation. Now in the first equation we got AE equal to AE root 3 equal to 80 minus x. Second equation states that AE equal to x root 3. Now putting the value of equation 2 in equation 1, we get x into root 3 equal to 80 minus x, or we can write 3x equal to 80 minus x. This implies taking x from the left hand side, we get 4x equals to 80 or x equals to 20. That means BC equals to 20 meter. Now BC is obtained, BC is 20 meter and total AB is 80. So AC is nothing but AB minus BC, which is nothing but 80 minus 20 is 60 meter. Now let's find the height of the pole. Height of the pole AE or PD equal to x root 3, which is nothing but 20 root 3 meter. Hence, the height of the poles are 20 root 3 meter and the distance of the point from the poles are 20 meter and 60 meter respectively is the answer. Friends, here is a few questions. We'll discuss some more questions in the coming class. Friends, practice more and more such questions, and in case you come across some difficult question, feel free to share your question with me. It will be helpful for you and it will be pleasure for me if I can help you out in solving your doubts and solving your question. This was for today's class. Thank you.